In this video, we're going to talk about percentiles, and they're used in statistics to indicate a value below which a certain percentage of the data values fall. For example, if you score in the 60th percentile in a standardized test, it means that 60% of the other scores were lower than yours. So let's say, I'm going to draw a picture, let's say this is you. If you're 60th percentile, that means 60% are below, and the other percentage that makes up 100, which would be 40, would be above. And we see these used a lot in healthcare too. So you can think of percentiles like with height. So if you're the 60th percentile in height, it means 60% of people are shorter, 40% are taller. And so a percentile or percentile rank, so those mean the same thing, of a data value just indicates the percent of data values that are below that particular value. So just remember the word below when you think of percentile. And so to compute the percentile rank, all you have to do is find the number of data values below, divide by the total. So n equals the total number of data values in the set, and convert that to a percentage by multiplying by 100. And then I also want to add here, you're going to round this answer, if you get a decimal, to the nearest whole number. So let's do an example. What percentage of the values in a data set lie at or below the 30th? So if it's asking for the percent below, well, that would be whatever the percentile indicates. So if a person is in the 30th percentile, it means 30% are going to be below. So whatever number is in the percentile describes, that's the percent below. And so this is going to be 30%. And then what percentage of the value in the data set lie at or above the 30th? Well, if 30% are below, then 70% must be above, because 30 plus 70 equals 100. So 70% are above. If 500 measurements were taken, approximately how many, so we're not looking at for a percentage, we're looking for how many would be at or below the 30th percentile. Well, if we know that 30th percentile means 30% are below, so we're just going to take 30% of 500. So we're going to take 30% would be 0.30 as a decimal times 500. And if we multiply those, we get 150. So there'd be 150 below. And similar question for D, except it's asking for how many would be at or above the 30th. Well, we know that above the 30th percentile is 70%, just like this picture shows up here. So we take the decimal for 70%, which is 0.70, and multiply by 500. And if we multiply those two numbers, we get 350. And so we could add numbers above to this picture. So if we had 500 measurements, so 500 total, then that 30% would represent 150, and 70% would represent 350. So the 30th percentile would have 150 below and 350 above. So let's look at example 2. Suppose you score 71 on a test of 10 people with the 11 scores listed below. What is your percentile rank? So if I'm 71, it means I'm right here. We need to find the number. So the percentile rank is the number of people below me divided by the total number of values times 100, and then rounded to the nearest integer, or the nearest whole number. So before I do that, in order to find the scores below, these mean nothing if the data set is out of order. So I have to first put the data set in order. So I'm going to go ahead and find the lowest number, so 52, and I'm going to put the list in order, just crossing them off as I go. So 64, let's see, 75, oh, yeah, 75, and then 77, and then 82, and then 88, and 90, 93, got another 93, and then 98. And I always like to double check by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, and it looks like I left one out. I did. I left out 71. See, it was a good thing that I counted. So I'm going to go ahead and I'm going to put 71 right here, and I'm going to put a box around it, and that represents me. And so now I can count how many below me. Well, there are 3 scores below, so I'm just going to take that number, 3, divided by the total, which is 11, and I'm going to divide that in my calculator, and I've got a decimal, so that gives me the decimal point 272727. And if I convert that to a percentage by multiplying by 100, so I could just do that right in my calculator, not 11, 100. And so I get 27.272727. And so I'm going to round to the nearest whole number. So this 0.2 tells me it's closer to 27 than it is to 28. So I'm going to say that I'm in the 27th percentile. That means that 27% of values are below. Okay, and then the other, so 100 minus 27, or 73% of values, are going to be above me. So I didn't do that great on the test compared to other students, is what this shows. For the next example, we're going to look at the heights in inches of a sample of 8 females. We're going to find the heights, this is a little different than the last example, that corresponds roughly to the 38th percentile. So if I want to find the 38th percentile, all I need to do is take the percentile times the total number of data values, and find well, let's do that first actually. So let's take the percentile as a decimal. So 38% as a decimal is 0.38, and I'm going to multiply that by the total number of values, which is 8. So there are 8 females. So 0.38 times 8, and that gives me 3.04. And I'm going to have to round here to the nearest whole number because I can't count 3.04 data values. So what I'm going to do is I'm going to just round to the nearest whole number, which is 3. So that's about 3 people. So I want to find the person that has 3 below. That's what I'm trying to find. That's going to be the 38th percentile. So I am going to first put these heights in order. So it looks like 59 is first, and then 60, and 62, and 64, and 66, and 67, and 69, and then 70, and I'm going to find the value that has 3 below. So that would be 64, because that would be the 4th value, because this value has 3 below it. So for my answer, I would say 64 inches, the person who is 64 inches, is the 38th percentile. All right, so let's do one more example with percentiles. So an admissions committee is comparing 2 students who are otherwise equally capable apart from their class ranks at high school. Amanda ranks 2nd, but she was in a small high school with a graduating class of 45 people. And then Daniela ranked 50th, but was much larger at 650 students. Which student has the higher percentile rank? So the nice thing about percentile rank is it shows you how the person is compared to other people. And it's hard to do that just with rank. So with rank, this means what place they're in. So if a student ranks 2nd, it means that she's 2nd place. There's only one student that came before her. And Daniela was 50th, but there were so many other students, it's hard to compare. And so what we're going to do is we're going to find the percentile rank by finding the number of people below the student divided by the total. So I'm going to start by looking at Amanda. So if Amanda came in 2nd out of 45, we have to find how many people below. So we're just going to do 45 minus 2 is 43. So 43 are below her. So then we're going to take 43 divided by the total of 45. And we're going to times that by 100. And we're going to round to the nearest whole number. So this rounded to the nearest whole number would be in the 96th percentile. So that means Amanda, so if this is Amanda, it means that she scored above 96% of other students. So 96% are below her and only 4% are above her. So she did really well. And then let's look at Daniela. So if Daniela ranked 50th out of 650, well, we can just do 650 minus 50, and that gives us 600 people are going to come after her or below her. And so I'm going to take 600, the number below, divided by the total number of people or data values, which in this case is 650. So I'm going to do 600 divided by 650 in my calculator, and then I'm going to multiply by 100. Go ahead and write that down actually, times 100, and I'm going to round to the nearest whole number. So 92.3 rounds to 92. So she's in the 92nd percentile. So compared to Amanda, if we draw a picture for Daniela, she scored above 92% of people, and there are 8% of people that are above her. So you can see there are more people that scored higher than Daniela than Amanda. Only 4% scored above. And so in the end, Amanda, even though they both look like great students, Amanda is stronger based on her percentile since her percentile is higher.